Hi everyone, welcome to lesson 2.1. This is the first lesson of unit 2, solving linear equations. So just a preview of the lessons that we're going to be covering in this unit. First, we're going to start off by finding square roots and comparing real numbers. And then we're going to solve one and two-step equations. Then we're going to solve multi-step equations. And then we're going to solve equations where the variables are on both sides of the equation. Then we're going to work with ratios and proportions, solving with ratios and proportions. And then we're going to work further with solving proportions. And then we're going to learn how to rewrite equations in formulas to solve for a specific variable in the formula or equation. So, on to today's lesson, finding square roots and comparing real numbers. Your learning goal is to find square roots, classify real numbers, and compare real numbers by ordering them from least to greatest. So, essential question here. 3 squared is 9, but what other number, when squared, also equals 9? Think about it. So, if you think about it, if you take -3 and square it, you actually get -3 times -3, and 2 negatives make a positive, so you also get 9. Now, a little calculator trick. So please take out your calculator. I'm going to do 2 things in my calculator. I'm going to do -3 squared, and then I'm going to do parentheses -3 squared. So there's a really big difference between them. One turns out to be negative and the other one turns out to be positive. Well, I just told you the -3 squared is supposed to be positive, so why does the first one say that it's negative? Well, in the first one, we didn't put parentheses around the -3. Therefore, the square was only being applied to the 3 and not the negative. So very important here is that -3 squared only means -3 times 3. And there's only one negative sign. So only the 3 is being squared and not the negative sign. So you have -9. If you want it to turn out to be positive, then you have to put parentheses around the -3. So this means -3 times -3, which is +9. So whenever we talk about squaring a negative number, we're talking about doing it this way. Therefore, when we take the square root of 9, doing it the opposite way, we actually can get 2 different answers. We can get +3 and -3. Since 3 squared is 9 and -3 squared is 9, then the inverse of that, the square root, could be positive or -3. So it's like, what could be the answer if we took the square root, if we did it the opposite way? So you're probably familiar with this symbol here, plus or minus 3. So that's what we would use. So this says to find the square roots of each number. So essentially find the numbers that when squared, and notice it says square roots, find the number such that when squared, it is equal to one of these numbers. So if you took the square root of 36, it would be plus or minus 6. And all of the ones here should be able to be done without a calculator. You should know these by now. These are called all of these are your perfect squares. Perfect squares. If it's not a perfect square, then you would use your calculator. So the square root of 49 is equal to plus or minus 7. The square root of 4 is equal to plus or minus 2. The square root of 9 is equal to plus or minus 3. And now this bottom part brings us to a different dilemma. So you know how I said when you take the square root, you gotta do plus or minus? But what if the square root is already there? then you just take the sign that's in front. So here, if the square root is already in the problem, then you don't have to do plus or minus. So this is just positive 5. This is plus or minus 8, since there was a plus or minus sign in front, so you just take whatever the sign is. This is negative 9, and square root of 121 is 11. All right, so speaking of perfect squares, it's the square root of an integer. So whenever your answer to a square root number comes out to not have any decimals. So if the radicand, in other words, the number that's underneath of the radical sign, we call this the generic form of radical sign, and this specifically is a square root, since, well, we could talk about that later. But anyways, the radicand is the number that's under here. If it's not a perfect square, we will need to approximate using our calculator. So here is a word problem example. The top of a folding table is a square whose area is 945 square inches. So it says that the area is 945 square inches, or inches squared. Approximate the side length of the tabletop to the nearest inch. So if we drew a picture here, oh wow, that is not the best picture of a square. All right, there we go. So it's a square, so that means the sides are equal. So you can use S or X to represent the sides. And the area of a square is just S squared. So if you want to find out what just S is, you would take the opposite, or the inverse, of squaring something, which is square rooting something. So you would square root 945. So let's pull out our calculators. And I don't know what the square root of 945 is. So I'm going to type it in, do second, and then the x squared. So notice I'm saying how x squared and square root are inverses. Notice how in your calculator, there's the x squared button, and then the blue button is the square root symbol. So oftentimes on your calculator, inverses will be paired with each other in a button. You'll just have to press second and then that button to get the inverse. So the number that we're doing is 945, and you get 30.74. So this is equal to 30.74. However, we do have to pay attention to rounding directions. It says to approximate the length to the nearest inch. So the nearest inch would be the ones place, so this would end up being 31. And then just inches, not inches squared anymore. Because when you take the square root of inches, then the square root cancels with the square, and then you just get inches for your units. Okay. Also, length is just one-dimensional, while area is two-dimensional, hence the unit being squared. All right, so here approximate the square root to the nearest tenth. So really all you need to do is type these into your calculator. I'm maybe just going to do the first and the third one. So for the first one, the square root of 32 is, and we're rounding to the nearest tenth, so that would be 6.7. And then for number 3, it's negative square root of 48. Now, what you can do is think about what this would be close to. So what number would the square root of 48 be close to? And hopefully you're saying -7, because it's very close to 48 is very close to 49. So to maybe guess what a square root is, think about what perfect square it's close to, okay? All right, so anyways, like for example, the square root of 900, you might know is 30. So the square root of 945 is just a little bit over 30. So negative 6.9. All right, so let's go ahead and move on. Let's talk about the different kinds of numbers, real numbers. So what is a number that's not real? Well, you may or may not have heard before, this is just a side note here, of an imaginary number. Okay, you can look it up, but essentially an imaginary number, let me show you something in the calculator real quick. What if we accidentally put the negative sign underneath of the square root? So we did the square root of negative 48. This says error, non-real answers. So this means that whenever you take the square root of a number, it's going to give you this error message. So we can't take the square root of a negative number unless we were in a class where we were allowed to use imaginary numbers. And you'll learn about imaginary numbers in Algebra 2 and maybe geometry, but definitely Algebra 2. So please do not do this. Maybe just pay attention because I don't want you to mess up your calculator setting. But I'm going to go in mode and I'm going to change my settings. Where is it? I'm looking for the imaginary setting. So normal. Here we go. So you see where it says real? The second one over uses the imaginary number I. So I'm going to use that number. So I'm going to click on that. I'm going to try typing this in again. So the square root of negative 48, and it gives you 22.09 blah, 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 I. Oh, wow, I typed in something really wrong. Let's just try negative 49 to give us a perfect square. 7i. So the imaginary numbers allow us to work with numbers that are negative under the square root. Anyways, let me go ahead and change that back to real. I just wanted to give you an idea of, okay, we're talking about real numbers, but what's a number that's not real? So that's what I mean by that. So the different kinds of, we're just going to work with real numbers in this class. And there's a type of classification system that we're going to be using. So first of all, you have rational numbers and irrational numbers. Irrational numbers are a number that cannot be written as a fraction of two integers. Its decimal neither ends nor repeats. And an example of an irrational number would be, for example, pi. Okay, pi is an irrational number, 3.1415, blah, blah, blah. It doesn't end, it never ends, it keeps going on forever and ever, and it never repeats. Also, square roots that do not repeat or end. Type in the square root of 2. The square root of 2 in your calculator. 1.41421. Okay, so the square root of 2 is also irrational because it's never going to end. Even though it looks like it ends on the calculator, it doesn't. It keeps going, and it never repeats. So I'm actually going to put those here in this diagram. So if you want, you can pause, copy down this diagram. So pi is irrational. The square root of 2 is irrational. And there are plenty of other square roots numbers that are irrational. So, for example, negative square root of 14. You can type that in your calculator to check that out, but it's negative 3.7416. All right, so that's irrational. In irrational, there are no other smaller classifications to irrational numbers. So if it's an irrational number, then that's it. If it's not irrational, then it's rational. So a rational number, it does end, or it could repeat, and it can always be written as a fraction. Even whole numbers can be written as a fraction. If you have 2, you can always put it over 1 to turn it into a fraction. So a real number, wait a minute, we're going back to real numbers. All rational and irrational numbers. So let's talk about rational numbers. So for example, well, actually, let's just go through this list here and then we'll talk about the difference. So rational number can be written as a fraction. An integer. An integer is a number that doesn't have a decimal. So no decimals. Integers, positive or negative, and no decimals. And then whole numbers are no decimals, but they're only positive. So just positive, no decimal. A lot of times you can think an integer is a positive or negative whole number, and whole numbers are like your counting numbers, like 0, 1, 2, 3, etc. It does include 0. So let's sort out these numbers into their smallest classification. So 0. So 0 is definitely rational. It's definitely an integer, and it's a whole number. So we would put it here. -4. -4 is rational. Is it a whole number? Well, no, because it's negative. So it would go in the integers because it doesn't have a decimal. 3/4. 3/4 can be written as a fraction. It's not an integer because it's 0.75. That if you heard that in the background, that was my dog shaking. -27. That would also be an integer. I'm going to cross these off as I go. The square root of 2, we already talked about that. That's irrational. The square root of 25. Well, the square root of 25 is just 5. So that would actually go in whole numbers because it's positive. Pi, we talked about that. -1 would go in integers. 16 is going to go in whole numbers. And then we talked about the negative square root of 14. -1/3 would go in the rational numbers. -1/3 is an example where it repeats. So it never ends, but it does repeat. So this would be rational. All right. Is there anything else on this page? No. Let's move on to our last example. So the last example we are going to, there are 2 more examples. This next example we're going to classify. So tell whether each of the following numbers is real, rational, an integer, or whole number. Actually, you know what? I'm going to have you guys do this in class tomorrow. Okay, so if you're watching this video now, you're going to be doing it during class. So if you want, you can think about what the answers would be, and you'll do your answer tomorrow. But I will do this last example with you. So graph and order real numbers. So order the numbers from least to greatest without a calculator. Okay, so put your calculator aside. So think, what is 4/3? Well, 4/3 would be 1 1/3, so that it would be 1.3 repeating. So that would be, let's see, this is -3, -2, -1, 0, 1, 2, 3. So that would be about here. So 4/3. How about negative square root of 5? Well, what's the square root of 5 close to is the square root of 4, which is 2. So this is like negative 2 point something, I don't know. We are just guessing, so say negative 2.2. I don't know if that's exactly it. I'm just guessing. So that's going to go about here on the number line. Negative square root of 5. The square root of 13. Well, the square root of 13 is between the square root of 9 and the square root of 16, which is between 3 and 4. So it's close. It's between the square root of 9 and the square root of 16. So it's about I'm just going to call it 3.5, 3.5. So the square root of 13. Negative 2.5 obviously is going to go here. So that's going to be the smallest one, the least. And then square root of 9 is obviously 3, so that'll go here. All right, and now we've ordered them from least to greatest. So this is the end of the lesson. You can go ahead and exit once this video is done playing. Have a great day.